Okay, hello all you crazy people out there. My name is Michael. I like wizards and dragons and making games, and I have a fairly unique problem here today in that I recorded an entire hour-long video of this and then realized that the recording was just like cut up in random places because I was using the F11 key for certain things in-game, and then apparently the F11 key was also the start and stop recording hotkey in OBS. I'm not honestly sure how that happens because last night I specifically went and removed the start and stop recording hotkey from OBS in anticipation that I might be using some of the function keys for things. I don't know if I just didn't hit save or hit cancel or something instead of apply in OBS when I did that, but in any case the recording is gone and I have to do this all over again. So today we're going to be talking about collisions, or at least collisions as far as building towers go. So you can build towers using a user interface now, which is great. That's pretty fun. You can also build towers in places such as inside of each other, and inside trees, and on the path, which is a little bit less desirable. You don't really want to be able to do that. In these real-time strategy tower defense games, space is a part of the game economy, and at least the direction that I'm going with this, I don't want the player to have infinite space to build stuff. Most people, when they play tower defense games, probably would welcome that challenge to have to manage their space wisely and not just build towers wherever they want. Some people may disagree. Some people may think it's fun to be able to spam as many towers in the same space as you want, but I am not making that game right now. In any case, that would probably look really cluttered, and I don't want that either. So we're going to be writing some collision code, and I'm not going to be doing 3D collision code the way that I did with the raycast for clicking on stuff in 3D space. I'm also not going to be using the 2D collision system the GameMaker provides. Some people like to use the 2D collisions for 3D games. That is perfectly valid. If that's what your game needs to work, go for it. I am not going to be doing that. I am a person who tends to, for whatever reason, end up using grids for collisions, including in situations where you would not necessarily expect a grid to be the best way to solve a collision-related problem. I'm going to be using actual DS grids. You could use a 2D array. I'm going to be using DS grids because they have some functions for things such as DS grid set region and DS grid get min, get max. The one that I'm actually going to be using here is max. A lot of people like to use DS grids as glorified 2D arrays. You can do that, don't let me stop you. That's not really the best use for them. If all you're going to be using a grid for is to put things in a position in a cell and then reading them back out later, you might as well just use a 2D array. First and foremost, you don't have to explicitly destroy a 2D array since those are garbage collected, whereas you do have to call DS grid destroy when you're done if you don't want a memory leak. DS grids do contain math functions. I made a video on these like 5 years ago, maybe even longer ago than that by now, and I talked about how the math functions are really where DS grids excel. They're not useful in a ton of places, but in places where they are useful, such as now, where I would otherwise have to write a two-dimensional for loop and nested for loop to iterate over a section of the array if I wanted to get the values in it or whatever, DS grid get max and DS grid set region are really nice. So, let's see. One of the unsung advantages of having my recording screwed up of this initially is that I now know pretty much what I'm going to do beat for beat, and I don't have to sit here and think about it. That's actually what I kind of wanted to do when I decided I was going to do this series, is sit down and think about how things were going to work on recording, because I want to show that process off a little bit, but for the sake of time, planning them out a little bit more is not a bad idea. So the way this is going to work, quick and dirty, is that the map is going to be split up into cells. When you build a tower or when you load in a tree or something from the map file, its corresponding cells in the collision grid are going to be marked as occupied, and then when you try to build a tower or something later on, if the cells that you're trying to place it on are occupied, then you just won't be able to. Later on in the video, I'm going to draw a little debug image of what the collision grid looks like in the game, and you'll be able to visualize it from there. So, I initialized the grid to a size of 10 by 10. Right now, the size of maps are more or less the size of the room. If I were to go into the room, this room is 1366 by 768, and that is... okay, sure, the map is decently big. This doesn't really mean anything. These are pixel values in GameMaker, but when you're in the 3D, pixel values don't really mean anything. The size of the room and pixel values doesn't really mean anything because like that is heavily dependent on your 3D camera and some other things, the perspective projection. Things are going to be scaled up and down all over the place in 3D. The maps themselves, over here in load map, the maps themselves don't have a size attached to them. They probably will eventually. Later on when I add some more data to the room, such as, for example, the skybox or whatever. I do need to go back and like put more actual thought into the environment of these areas. Anyway, whenever I go and do that, I will attach dimensions to these rooms, to these maps, and then when I load them out, I will resize the grids based on the size of the map. But now, I'm gonna say width WW is going to be room width integer division. Let's say 4, or HH is room height integer division 4. If you've never seen it before, the div keyword is integer division. I'm going to be using it in a couple of places in this video. It's essentially rounding down. It will produce the same result as a value just with a slash and then a value and then rounding the whole thing down. Specifically, integer division treats the two operands as integers. Integers being numbers that have no fractional part, they're just whole numbers. In GameMaker, pretty much every number is going to be a floating point value, so if you divide 5 by 2, you'll get 2.5. In computer languages that have static typing, that have integer types, if you divide 5 by 2, you will get 2, because there are no fractions, and you're effectively just rounding down. That's not often needed in GameMaker, although it does make sense to round down when you're dealing with things like array indices, which I will be here with the collision grid. It doesn't really make sense to create a DS grid with a width of like 2.5 or whatever. So, DS grid resize. Collision grid, we're going to be resizing it to width and height. And then DS grid clear. And we'll be initializing it to 0. So the way I'm going to be doing this is very simple. If the value in the grid is going to be 0, then that means the cell is free. If the value in the grid is 1, that means the cell is occupied. I'm not going to be doing anything fancy with like putting a reference to the object that is in a position in the grid at the position in the grid. That won't be necessary. This 4 value here, by the way, the value that you're dividing by, the value that I'm dividing by, is kind of arbitrary. If you go look at the room test, this is a grid which is 32 pixels wide. If you were to instead say a 4x4 grid, you'd have much finer resolution, and it's not actually going to draw this unless you zoom real close in. In the case of this tower defense game here, the cells in the grid are going to be fairly small, and there will be a lot of them. Towers and trees and stuff may end up taking up more than one cell in the grid. In fact, almost all of them will end up taking up more than one cell in the grid. Making them 4 units wide here is kind of just an arbitrary value. If that ends up being like excessive and just a waste of space, then I'll increase it to like 8 or something. We'll see. I also would like to go into the macros function, and I would like to clean this up. This was driving me crazy when I was editing the last couple of videos, all these color RGB macros. I'd like to consolidate these all into a single color value. I'll deal with that later, either at the end of this video or at the end of the next video. And I'm also going to say grid cell size is going to be 4, and we're going to be using grid cell size instead of a hard-coded value of 4. I suppose, and I can do this too, grid collision free is going to be a macro of 1. Collisiono. Sorry, free is going to be 0. Did I say it was going to be 1? And grid filled is going to be 1, as I mentioned before. So now we can just clear the grid to grid collision free. The next thing we're going to want to do, and I am still recording, right? And I didn't hit any magic hotkeys that would just make that stop happening. Good. So the next thing that I'm going to want to do is actually have things be added to the grid when when they are loaded into the game, when they are spawned in. First, I'm going to make a commit. By the way, if you're looking at the commit history of this repository and you see 5 undone commits and then redone, yeah, that is because the recording got chopped up into little tiny pieces that I am not going to assemble because a lot of it is missing. Let's see. Create the collision grid. So there's something that I should probably have done a long time ago from the start, and that is all of these DS list add all entities, all environment entities. It would be nice if I made these methods inside the entity object. I am going to create a method called add to map. And I'm also going to create a function called add collision. I'm going to fill these in one by one. Add to map for most entities is just going to involve DS list adding itself to these lists. And then here, for example, I could just call ent.add to map like that. This is going to be, the implementation for this is going to be different for different kinds of entities. The one that I was just messing with here, the environment entities, which are things like the flowers and the trees. Here, this is going to have an add to map function. Method, which adds itself to the all entities list, which is the list that the game iterates through when it draws everything and updates everything, and the all environment entities list, which is for the benefit of the editor. So instead of saying ent, we're going to say self, self, and since we are no longer in the scope of the world, instead of saying all entities, we are going to have to specify game.allEntities. Okay. So different kinds of entities are going to have different implementations of this. This is environment entities. There are towers. There are bullets, which are going to have their own implementation of this. Bullets do not need to be added to anything besides the entity list. Towers should be added to the tower list instead of the environment entities list. So game.allTowers, and I believe foes, if I recall from my botch recording, also have a similar list of foes. Game.all foes. And I think that's all of them. If I want to find instances of where this is happening, some of these are related to the stuff on the screen, to the entities. Others are things like the UI elements, waves. This is a global search of the code. It's not looking for any specific thing. This is when you spawn a tower, so I could say tower add to map. It may make sense to put the add to map code inside the constructor itself, but I do want to separate them. There may be times where you want to create an entity without actually adding it to the map for temporary purposes or something like that. In fact, I am pretty sure I will be doing that later in this video. You'll see what I mean then. Let's see. Where else is this done? This is when you spawn in an environment entity, when you click. So we can say ent.add to map, like this. I think that's it. The only other place I can think of was when they were being loaded out of the file. Okay, I think the only other place where this would need to be done is, if I recall, in tower. Let's see. Let's X out of that. Entity tower. When you shoot something, you will be creating a bullet, and DS list adding the bullet. Like this. I think now I can just run the game and expect everything to be refactored properly. Okay, and nothing at all is visible. There is an error popping out in the console. And, oh yes, okay, that makes sense. Okay, I was gonna have to deal with this eventually. And I guess eventually is now. So this is complaining about game not existing in this line. Entities line 72. G control G 72. This variable does not exist yet, or at least it exists, but it doesn't have a value yet because it's a macro pointing to something. And that is because the code that is running that is load map, which itself is happening inside the constructor for the game object. And that's not going to work because while you're still in the constructor, the object doesn't actually exist yet. If you assigned the return of the constructor to a variable somewhere, that won't have happened yet. And then if you try to run that code, it's going to be a big mess. So now I really should wait until all the initialization is set up before calling load map, and then once the constructor has exited and game equals new game, and this now has a value, because this is really what the macro is looking at, then it's safe to call load map. All right, doing stuff in steps. What else is there? If I run the game now, that should work without spitting out anything in the console. Yeah, there we go. Okay, everything is loading. I can create a tower. It's going to be there. I can create another tower. I can hit the spacebar, and they are shooting, which is wonderful. So that's worth another commit. Next, there is the matter of the collision grid, which is actually the point of this video. So the collision grid adding code isn't really going to be different for different types of entities that try to implement it. So I'll just do this in the base object. First, we want the bounds of the object. I'm going to be ignoring rotation. I'm just going to be going into position, bounding box, and scale. Everything has a bounding box, and the bounding box is a struct containing 2 points, and a point is a vector containing x, y, z, and whatever else you want it to contain. We are going to get the bounds of that in world space first. So we can say var x min is going to equal collision.p1.x times scale.x, and y min is going to be collision.p1.y times scale.y, like that. X max is going to be p2 instead of p1. I'm pretty sure in the bounding box this is ordered, or at least when I create the bounding box, this is ordered. P1 will always be smaller than P2. Just in case that is not the case, I will use min and max, the functions, to force it that way. Let's see. So instead of just saying the minimum position is the x min times the scale, and the y max is the y 2 times the scale, or whatever, we are going to be evaluating them both, and then picking the actual minimum and maximum values. And that should prevent things from getting weird. The next thing that we're going to want to do is convert this into cells on the grid, just the way that in load map the grid is the room width divided by the grid cell size. To convert the position of each of these objects into coordinates on the grid, we simply divide x min, y min, x max, y max by the cell size. So that can be grid cell size, and then we can do this for y as well, and then we can do this for the maximum value. Rectangle select is amazing. If you don't know how to do this, if you hold down the Alt key when you click and drag, you will select a region, which you can do whatever you want to, rather than I didn't actually want to do that. Rather than just selecting an exact point on an exact line. It's great. Let's see. So this should be good, I think. This is going to round down. For x max and y max, it's going to round down, which is probably not what you want, because you want the actual position in the grid that is being filled by the bounding box, and not the and not to have the maximum values rounded down one cell, because then you'll kind of be missing one. I'm going to add 1 there. Technically, if the maximum position of one of these bounding boxes is at an exact multiple of 4 or at an exact multiple of grid cell size, it'll be one value too big. It'll be one cell too big. That's not really a concern right now. The cell size should be small enough that that's not really hugely bothersome. Although if I find out that it is, I will just use like some other, I guess, seal like this. You know what? There's no reason not to do this right now. It's not like it's more work or anything. Okay. I've been rambling a lot today. So we can say ds grid set region, as I mentioned before, and this will be game.collision collision grid. And it's going to take an x1, y1, x2, y2 and a value. The x1, y1 is going to be those. X2, y2 is going to be those. And the value is going to be 1. Actually, no, it's going to be grid, what did I say? Grid collision filled. The macro, which happens to be 1. Okay. This won't do anything because this is not being called from anywhere, so let's just call it in whatever add to map functions, whatever objects would want themselves to be added to the map, which is pretty much everything except the bullet. The bullet should not be added to the collision grid. Environment entities should be, these are towers. Towers should be, enemies should be, this is enemy, right? Yeah, this looks like an enemy. And I think that's it. Later on, I'll get to path nodes being added to the grid as well, in some way or another. But this will do for now. So now nothing's going to actually happen because the collision grid information isn't looked up anywhere. I can still place towers on the path. I can still place towers in a tree. I can still place towers on top of other towers, as long as I'm allowed to click. That doesn't look right, but we're getting there. We can commit this change like this. We can look at how long I have been recording. Let's see if I can do this in less than an hour, which is about how long it took the last time, and I definitely want to speed it up a little from there. Okay, next thing I'm going to do is debug. So I'm going to write some debug code. I'm just going to make a file called debug. Should I write other debug code, it'll go in here. I'm going to say function, no, debug, draw, collision. And let's just give this an X and a Y. This will draw a debug version of the collision grid. This is going to happen in the draw GUI event, so we don't have to mess with like surfaces in 3D space or anything like that. But let's see. First, we will say, and I don't know what the default draw color is, so I'm going to manually get that value. And then set it back at the end. The word color may or may not actually have a U in there. And then we'll set the color. We're going to draw a black rectangle. That's going to be the background of the collision grid. So we'll say when we're representing it visually, black is free space and white is filled space or something like that. And then draw rectangle, and that'll be at x, y, x plus ds grid width. Each cell in the grid is going to be represented by 1 pixel on the screen. We will draw the rectangle to be the height and width of the collision grid. That'll be 1/4 the size of the game room, since each, or really 1/16, since each cell in the collision grid is currently 4. And then we can iterate over this with a for loop. This is going to be slow. This is not something you want to do during anything that isn't like a debug event. I wish there was a way that you could do things like convert a DS grid straight to a buffer or something, because that would allow you to do some interesting tricks, turning the buffer into a surface and then just drawing the surface or something like that. But alas, we have to manually draw all this. Next, we will say if game.collisionGrid at that position ij is equal to game grid collision filled, then we will simply draw a pixel there. Not draw pixel, draw point. Draw a point there. And that's going to be x plus I, y plus j. And the color should be white. I should draw set the color to white. And this should draw our debug collision grid. Let me go to the draw GUI event, like this. And I will say, if you're in edit mode, if you're holding down, I made it the F11 key, which happened to be the key in OBS that stopped the recording. So every time I did this, it started and stopped. If you're holding the F11 key, debug draw grid, debug draw collision, and we can make this out like 32 or 32 or something that's just away from the side enough that it's not like it's not obscured by the debug overlay at the top of the screen. And just because I want to make sure this is not messed up, you'd better not. I will be keeping an eye on you, OBS. Alright, let's run the game. And if I hold F11, there's going to be a syntax error somewhere because I'm missing something. Alright, for one, this should be height. Oh, okay. Draw set color was not closed off at the top there. Oops. Good thing it wasn't worse. Let us go into edit mode and hold F11. And you can see there's a grid being drawn. This is a little messy. It doesn't exactly look like the stuff that's actually on the screen. Part of that is due to the size of the bounding boxes. I don't believe the 3D objects all have bounding boxes that are of sizes other than like 32 by 32 or something. Because the bounding boxes I don't think are actually loaded from the file. There's also the matter of the really small things taking up more space than they should. If I were to create something, if I were to go back into gameplay mode and build a tower, you should see something was placed down. You can see where the tower is, one, by the section of the rectangle on this grid that wasn't there before, and two, it's slightly bigger than everything else. I believe the towers have a bigger footprint than stuff like the trees. It's this one over here. If you can see my mouse cursor, I will highlight it in video editing in a certain color or something like that. Okay. Once again, this won't actually do anything because this information is not used. The collision grid information is not used. I can still build towers on top of each other if I can get them close enough to place down without selecting the other tower like that, which isn't really useful. This is the collision grid. I will commit this all the same. In the name of making that make more sense, where are the 3D model data that is loaded in? The environment objects. Load model. Okay, so I believe I mentioned that I would be doing this at some point in a long previous video, a long time ago, and I don't think I actually ever did. It would be really helpful if I could return bounding box information from load model. Probably the reason that I didn't is just because this just returns a vertex buffer, and it doesn't return like a struct containing that vertex buffer with other information or anything like that. Okay, I will write down to do this in a future video. That is more of an endeavor that I am willing to take on today. So the last thing that I will do today is when you spawn a tower, which is the spawn tower function, making sure the area is free when you do that. So I'm going to make myself a function called collision free, and I'm going to call that. It is going to take a parameter, which is an entity, and we're going to be looking at its collision information. This is where I talked about having entities spawned without actually being added to the map. What I'm going to do here is instead of spawning the tower only when you actually click and when you verify that that it's a valid space to be clicked, that it's a valid space to be located, then you're going to add it to the map. We're going to add another condition onto this if statement that says, and collision-free tower. And this is going to make sure that you can actually place the tower down in a location. One thing I should do is check the position first. Because if position is non-existent when you try to do this, then bad things will happen. Because position can be undefined if the mouse doesn't actually intersect the floor at any point. But otherwise, when you look to see if you can place a tower down, you will want to already have the tower's position and size and all that. Okay. Collision free. How is that going to work? So over here in the add collision function, it does this calculation. This gets the cells inside the collision grid that an entity takes up. We're just going to copy and paste that. I am okay copying and pasting in this situation because I don't think this is going to have to be done at any other point besides this. And it doesn't offend me to have code copied in 2 places as much as it offends me to have code copied in many places, and with the potential for more in the future. So this is going to be where the dsgrid max function comes in. dsgrid max, dsgrid get max. There we go. This is going to be where the dsgrid get max function comes in. This is going to be x1, y1 of cell x min cell y. You know what? Hang on. More copying and pasting. I'm not sorry. The arguments are going to be this, same arguments as when we were setting the grid before. And we're going to be saying if this value equals grid collision filled, we're going to be returning false. Else return true. Those of you who like to do code golf may realize that you can say simply return this is not equal to grid filled, or maybe perhaps it is equal to grid free. This is honestly fine. I guess I'll write that. I'm trying to keep clarity in mind, but this is decently clear what it does. If you were specifically thinking that free is 0 and filled is 1, you could also say return like not the value of this. Return the negated value of this. I am not going to be doing that because that is not clear whatsoever what that value is and why it's being negated. I would do that when I'm writing my own code. I would not do that when I'm writing code that other people want to read. Okay. This should be all I need. I am now 42 minutes into this recording instead of an hour 10, which is what I was more or less the first time, which is an improvement of 20 minutes. Let me try and spawn a pebble shooter. I am able to spawn it on top of there. And I'm not able to spawn it on top of the ground, so there is oh, the negation is still there. I do not want the negation to be there. Okay. The code works. I just left scribbles all over it from when I was noodling around. Okay, so I cannot place stuff on top of the path because there are objects on top of the path. I cannot place it in the tree. I can place it on the ground. If I place it, I can place them next to each other. I should not be able to place them inside each other. Good. This works. I'm going to call it here. There are other things related to collision and placing towers that I want to do. I wrote some down at the end of the failed video. I'm still annoyed that I lost an hour doing that. Anyway, some other things that will need to be done would be removing stuff from the collision grid. If you go into edit mode and delete a tree or something like that, you would want to remove it. You would want to probably indicate to the player that where you're trying to build a tower is not a location where you can build a tower. Have it flash a different color. Speaking of colors, I want to clean up the color macros. That's not macros. These look really bad. I can clean this up, and I should clean this up so that it doesn't look so bad, and so that the code where it's used isn't so messy. Marking objects is not added to the collision grid. Things like flowers. Flowers, realistically, it's okay if you build a tower over. They're mostly going to be clustered together around things like trees and rocks anyway. They should not be just floating around in the middle of the map, taking up space, as well as the tile stones themselves, the flat rock objects that are in the map. I don't actually want those to mark the collision grid as filled. Instead, I want to use the path nodes and use those to mark the collision grid as filled. Okay. That should be enough. My name is Michael. I like wizards and dragons and making games. Did I commit this last change? I did not. I should commit this last change. I hope you found that interesting. If you want the code for this, as you can imagine, there's a link to this GitHub repository in the video description. Look for the 0.21 release, the week 21 release. If there are any future releases after that, then that'll be future weeks that I've worked on but not posted the videos of yet. I have a Patreon, so if you want to contribute towards these being made, there's links to that in all the usual places as well. I try to post 2 of these videos a week, 1 of these and 1 tutorial. Once again, I hope you found that useful, and I will see you all later. Special thanks to Edward Holt, Indie Punch, Jason, and Zenith for supporting these videos. If you want your name in the credits or to hear yourself shouted out at the end, head over to the Patreon page in the video description to join the fun.